right? So for the structure of the artery and the vein, notice that we have generally the three structures. So the same thing for the artery would be the same thing for the vein. We'll have tunica externa, tunica media, tunica intima, right? Tunica externa, tunica media, tunica intima, right? So generally, both of them have three tunics, right? What are the differences that we can see between them, right? Okay, let's just assess, right, the function of everything. Let's just do that again, and then go through. Can you guys hear me?
Yeah, we can hear you.
Okay, hold on, give me one moment. I accidentally signed out. All right. Okay. So, my bad. All right. So we have these three units, right? All of them have these three different tunics, right? So for the smooth muscle, we know that the smooth muscle, right, is more prevalent within the artery, right, than the vein. Right, so the smooth muscle is more prevalent within the artery than the vein, and we know the smooth muscle, its general function is to perform vasoconstriction or vasodilation, right? So we know that it does that. It also can help withstand the pressure, right? The high pressure that is carried that the blood is carried under in the artery. So you can know why the artery has significantly more elastic tissue, elastic membrane, right, and elastic fibers and smooth muscle than that of the vein, right? Because the vein doesn't really carry blood under high pressure, but it still needs the muscle because vasodilation and vasoconstriction will be present for hemostasis, not for hemostasis, for hemostasis, right? Yeah, right. So we have those. So we have those functions of those, right? As I can repeat, the vasovassorum, right, would be used to maintain blood supply to the different muscles and different cells that exist within these different structures, right? And for the nervi vassorum, right, the nervi vassorum specifically, right, helps with the nervous system coordination, right, within the different temperature receptors within the skin, right, causing blood vessels, right, to, well, transmitting the information to the smooth muscle in the blood vessels, right, for vasoconstriction or vasodilation to take place, right? So we know that when it's really cold, vasoconstriction will occur. When it's really hot, vasodilation will occur. So the nerve ivosarm kind of helps with that. That's the question.
Seeing your screen.
Oh, okay. Let's see the screen. Sorry about that. Okay, so we have that there. For yeah, so we went over all of those before, though, when I was drawing them. All right. So notice this now. We need to note the differences between them now. For the tunica externa in the vein and the tunica externa in the artery, notice that the vein has a larger tunica externa, right, as compared with the artery. So the tunica externa in the vein is larger, right, than the tunica externa in the artery. We can note that. The tunica media in the vein, however, is smaller than the tunica media in the artery, right? And the tunica intimas are relatively the same, but we don't have elastic enough, well, the same amount of elastic fibers, right, within all three tunics as with the vein. So we can that can be explained, right, by the pressure, right, of blood, right, by what it's doing. So structure can always relate to function. So arteries contain blood moving under high pressure, so it's gonna need these elastic fibers. It's gonna need more muscle mass, so it's gonna need more tunica media, more so than tunica externa, right? So we can know that the function relates, well, the structure relates to its function in that way. While the vein generally it does move blood, right? But it will need the help of skeletal muscle, as we'll look at, right, specifically for the vein, right? So we have this there, right? Notice that within the endothelium of the vein and the artery, we have what is known as baroreceptors. So the baroreceptors and chemoreceptors. So it would be chemoreceptors, right? So we're gonna have chemoreceptors there. So these are present within the endothelium, right, to detect changes in pressure and detect changes in chemical concentration, right? So we know that if we detect these things, then the veins and the arteries will manipulate their functions to, complete homeostasis, right? So if there's a lot of pressure, right, then that information would actually go back to the heart, right? Because if the pressure is increasing, then we're gonna look at what the sympathetic and the parasympathetic nerve does, and the chemoreceptors will actually regulate something else, right? So we're gonna see if there's a low pH in the blood, high pH in the blood, and how the body reacts to that. So those should be the main things that we know about the structure of the arteries and the veins, right? So that should be fine.